Hello, I'm back on the same day. So I decided to try to be my best to be productive and yep, work a bit more today. I think it's supposed to look like that. Having trouble with the mic. Hello, it's me. Okay. Um, seems good enough. So let's start the modeling. So a bit of context. I found a really good laptop dock design online, and I want to implement it to my desk workstation. um, I hate to admit it, but that design is better than mine in every single way. So I need to find so I want to find a way to adapt to it. And if you watch my previous video, you might have found out that design. But um, so in summary, in summary, the laptop will now be horizontal instead of vertical, and it can accommodate a wider range of laptop dimensions. So that's all good things, right? Now the bad thing is that I have to remodel the cable dock, the cable, um, the cable jig, yeah, because it most likely doesn't work because he has a Mac and I have a ThinkPad, so I have to model that. Plus, I have to remodel a couple more things for this thing to work. So I have to model like I have to like model for all the ports. I was thinking modeling for the HDMI port or something like that, but we'll get to that once we cross that bridge. Okay. Now, this is about the dimension of my dock because I just trade in the laptop, the old dock, for this new one. I now need to remodel it because this one has an Ethernet port, an RJ45 port in the back, so I have to draw everything again because the last design just covered it up. So let's get to it. Oh, and also this one needs to be this one needs to be able to attach a heatsink to it because this thing gets super duper hot when you when used. Okay, enough of the monologuing. Let's get to modeling. Okay, XY plane, perfect. Um, yeah, the thing. Let me check it a bit. The thing will likely work in this direction. So let me check it a bit. RJ45 orientation. It shouldn't matter, to be honest, but I want to check. I don't think it would matter to me. I just need to look for a way for this to work best. Okay, maybe like this because I have a heatsink and I want to mount it as best as I can. Okay, this is gonna be hard. Not gonna lie. If we go with like if it go like that, USB, HDMI, HDMI, huh? I think the HDMI can work from the other side if because I don't want to cover up the LED like that. Okay. let's go that route. So let's get measuring. .48 point. Okay, this is 48.32. Let's measure it from a different place. 48.5. .33. Okay, I'm getting multiple different measurement here. 38.45. So let's round that up to 48.5. I think we can have pretty good clearance right there. 48.5 millimeter. Already accounted for the clearance. And 48.5. Good number. So let's get our tool, rectangle, 48.50 millimeter, and the length will be, it's really long. The length will be, no, I need to make sure it is completely flat on along the length too. Total length would be at 136.55. So we can round it up to 136.60. 136.60. Let's measure it again. 136.60. Let's double check it. Okay, 36.60. Good. Okay. Okay, since we are modeling for the thickness only, this is good. Okay. I should name it top profile. Create a path operation. Now for the thickness of this thing, the thickness is always the annoying part because this thing is definitely not flat, not a rectangle. 17 17.8. Let's round that up to 17.1. Let's measure it again. At the fattest part, it would be 17.2, 17.3. This is super sensitive, so even if it is touching, just with just teeny tiny amount of force, it change. So, but I will give it 17.3. Yes, 17.30. 17.30. Okay. Say dot thickness. Okay, we got the thickness up. This is top surface. Now we want to work more on the bottom surface right here, and we will do that by creating a datum plane. Perfect. We should name it, right? Okay, should name it bottom plane. Alright, now we will create a sketch on no, I haven't. So like you have to select this and select it first and then create a sketch. Now toggle the visibility and create some external geometry. So we will reference this side. This is bottom, right? And wait, this is the bottom, so it will go in this way. Alright, it will go in this way. So I'm making an LED cutout, and okay, this is correct. Bottom. For some more measurement. From the top in, it would be using a step measurement to be exact. Okay, from the top down it would be 7.05, but let's give it at 7. 7 is good. So we will now create a rectangle. A rectangle. Yeah, shouldn't divide it first. Distance from here to here is 7 millimeter, and from the side is much harder to determine due to it not being a rectangle. But I roll it. It should be around 6. Should be 6, right? 7 also, because there is a lot of, no, not 7. Yeah, definitely not 7. Something on the line of 6. Yeah, something along the line of 6 millimeter is more appropriate. So this side is 6, and so is this side. I hate it when when the program does stupid shit like that. Okay, now we want the, actually we don't have to do that, but okay, we want the width of this rectangular cutout, which would be, I'm trying to hold the caliper still, 16 millimeter. Alright, so step right it, dimension of 16 millimeter. What's wrong? Can I set it to make distance? Oh, alright. I hear you. Oh, I've been mistaken. This side is 16. Alright, I have been defining the wrong edge. Okay, we got that down. Nice. Close it. Nah, I think we can do a bit better. With our newfound skill, we can give it a chamfer right here. Yeah, right here in the design. And we will do it by to be honest, this is the first time I'm doing it, but I think this should be it, right? So more like 3 millimeter chamfer. No, okay. So from this point, and it must be tangent. I select this point and this line, it should also be tangent, and we will change. No. Okay, how do we do this? I'm just trying to trim it down so we can get a good chamfer. I don't know if we should do it in this phase yet, but I want to be able to define it, so in the future we don't have to worry about the chamfer messing things up. Okay, definitely not that. How do they do it? So it is more like a circle going this way. So in my imagination, it is something going to be, first it has to be tangent. Alright, and we will define maybe some parameter. So can I change the radius of this thing? Apparently not. No. Okay. Yeah, that's not the way. Just messing around. You know what? We can mess around later. Let's not waste our time on this. So we will name it. Of course, naming thing is important. Easy. LED cut out. Boom. And it would be a, wait a minute, I forgot to add the material for it. Anyway, we'll come back to it later. So we carry a pocket which will cut through 3 millimeter of material, and okay, LED cut out. fix the dock sketch a bit because we forgot to account for the thickness of this thing. So we have to increase this by 6mm because we have to add 3mm on both sides. So it will be 51 plus 3 will be 54mm, and this will be which will only need to it will only need to accommodate for one it will only need to accommodate for one hole, so only 139mm. Perfect. Will this break the sketch? Let's check it. So I already cut out. Yep, the distance will be still 7, which is wrong because we are counting 7 from the inner diameter, so this should be 10. Oof, rough. And this shouldn't be 6, right? Yeah, it shouldn't be 6. It should be from the outer, so it would be 9. And so does this 9mm. Now let's double check the calculated dimension with the actual dimension. So the real one is 37 maybe, yeah, 37mm. Let's check the matrix diameter. 36.5, so something's wrong. Might have been a bit tight. So this one shouldn't be 9, should be around 8.5 perhaps. 8.5. So yeah, could be 37. Okay, it's not nice thing to know. We caught it early and we managed to fix it. 37. Wait, what? Now it's 37.5. I don't remember the decimal. We could check again. It's definitely 37. So we have to cut it by half again. So only 8.25 by 8.5. No, okay. 75. Now the dimension is 37. Okay. Good. Close the sketch. And alright, we got what we want. Now let's create a cutout for our hub to slide in. Now the hub we only need to accommodate for one arc, right? So shouldn't be too wide. I'm thinking I should cover that hole too. is yeah, let's use that measurement. It's not eyeball. Ten. No, only 9. Let's keep it 9. Bring it down. No, I think I can move a bit more up here. It's almost 10, to be honest. It's almost 10. So the best we should round down is round out to 0.5. Yeah, 9.5 is a good number. So let's do it. Select this plane, create a plane. Okay, we'll call it F2 front plane, and we'll sketch on it. Turn off and create some external geometry. Alright, bottom, good. Now the shape is another rectangle, and this thing we should measure is 9.5 millimeter. So let's do that. 9.5, 9.50 millimeter. And the distance from the top is .5. I think I should keep it 0.5 because there are gonna be a lot of error. Yeah, 0.5. So like 5 millimeter from this side to this side. Dimension should be 5 millimeter, and so as for this. Okay. Now for the the length of this thing, right? We have distance in, now we need the length of this thing is 7. I'm gonna keep it a bit bigger with more clearance, so I'm giving it 8 millimeter. 8 millimeter. And let's check the dimension of this. It's currently 7.3. Let's check for it. It is 6. 7.30 is actually a bit too much, but I'm gonna let that slide. Yeah, I'm gonna let that slide. Okay, seems to be good. Okay, cancel this. 9.5. Let's double check again. seems to be very much in order. Okay, let's create a hole for it. Three millimeter of material. Boom. We'll call this Thunderbolt cut out Thunderbolt cable. Alright. Thunderbolt cable. Alright, we got the holes in. We need to cut up the slot for the entire thing to go in from this side. So we'll create a datum plane. Okay, create a sketch on that plane. Boom. And something is wrong. Okay, is this the datum plane? Right. So we'll select it, create a sketch. Alright, this is the good normal order. Toggle the visibility. Should be below, right? What's going on? So let's just delete the datum plane right here. Alright, the pocket operation is the last operation, and this is the rear. Nothing unusual about it. Datum plane, and I'm going to name that plane rear plane. Okay, not rear plane, rear plane. Alright, sketch, toggle the visibility and some geometry for it. This one is easy because we know the constraint that we want already. So we can just input it in because this will not change. Insert for hub. Alright, we'll create a pocket operation, and we will punch through, definitely not through all, but I forgot the number. Let's check the dock thickness. Top profile, this is 139.6, so we will cut through 136.6. Alright, we will cut through 136.6 millimeter, 0.63 millimeter. Alright, boom, boom. That's what I like to see. Okay, good. I save it. We will call it okay, cut, and now to model the side. This thing, it's much easier. So you go how to slide dock in. It's stupid naming. I really need to take a course in naming stuff because I'm really bad at it. Okay, let's continue. This one will be all the fancy port in here. So come to think of it, I'm doing this thing in reverse, especially the placement of this thing, because the USB port is in all the wrong places. What if I do this? This is fine, but it's gonna take up. Do I really want to do this? Everything will be reversed, but I'm not going to touch any of them. Yeah, I'm not going to touch any of them, to be frank. So yeah, why not? Yeah, why not do it? Just do it. Okay, measuring time. This would of course be a rectangle. Let me make some measurement. Let's create a datum plane first. So this plane here, create a datum plane, press OK. We'll call this the left plane. And create a sketch on it. Turn it off and use this as reference. Alright, let's start measuring. So it will, I will decide it to be 29. No, it will be 30 millimeter. Let me plug it in to check. Yeah, 30 millimeter is right there. Not touching. I can attest to that. Okay, 30 millimeter it is. But this is from the rear, so we have to accommodate for the thickness of the material also. So it would be not just 30, but have to be 33 millimeter. Boom. And from this side, the left side doesn't have to accommodate for the material thickness at all, so we can be a bit more generous. can be exactly 30 millimeter. Yep. Since USB port usually a bit more bulky than USB-C, so 30 millimeter. Boom. Now these dimension. Wait. Oh, I mentioned the wrong side. Give me a second. That side is not supposed to be that. It should be only 10. Should be only 9. 1, 2, 3, 4, 4. So 14. Yeah, 14 millimeter. 14 millimeter. And from the top, I don't know how to give it, but I will say it has a bit more like millimeter more material. I'm considering it, giving it all the material it needs, all the clearness that it needs, because yeah, this thing gonna take up the whole space right there. I don't want to risk anything, so let's just keep it full. So I feel like I'm doing really redundant stuff, but so let's just keep it tangent and this thing tangent. Okay, we got a sketch for that. Give it a name. Give sketch a name first. Charger, HDMI, and micro SD. Yeah. Okay. Create a pocket with 3 millimeter. Oh, I forgot to accommodate the thickness of this thing. Alright, let's come back to fix it right now. So we delete the constraint about tangency. This one click now move. I forgot about the thickness of the material. So the dimension for this would be 3 millimeter. So does for this one. Okay, something is off right here. I don't know how it gets off like that, but what the heck? Oh, I have a feeling. Okay, something is wrong, I can tell it. Are they really even? Okay, that's what I'm not understanding. I'm not selecting any point. I literally just create a rectangle, and why does the rectangle breaks? Huh? How? Okay. 14, 33. Okay, let's delete it. 14 and 33. Oof. sketch on that plane. Oop. I'm gonna put on some music. I don't care if I got copyrighted. I'm not doing this video for money anyway. Let's pick something fun. Constant moderator should be good. Oh, the feedback. I'm gonna turn on the mic for now. but it works, so I'm gonna take it. I thought I would need to close the constraint a little bit, but yeah, this doesn't seem like I need to. Okay, I think that is it. Oh yeah, forgot about the mounting solution right here. I'm thinking something that is built in, so we'll put it in, screw it in, then mount it. Yeah, so let's check. What do we have? We want to find some screws with M3 dimension, right? It's good starting point. Here, okay. Dimension of M3 is good. We don't need. I don't think we need bigger than this. Length will be the thickness. If I remember exactly, this is something like 1 centimeter. No, it is 100. It is 10. No, not really. It is 10. 1, 2, 3, 13. Only something. Let's give it 14 millimeter for some clearance. But yeah, good number would be like 2 centimeter. 2 centimeter of desk. Okay, so something less than 2 centimeter of desk for me should be good. So around this, perfect. Alright, something in the upper corner, something like this, because we have to accommodate. Alright, oh, this thing is flush, right? Alright, let's design it. Should be the plane we used to. Create a plane. Okay, let's name it mounting plane. A sketch on it. X-ray mode. I don't think we need X-ray. I don't think we need any reference from here. We can just take the hole, 3 millimeter. We will need 3 of them to create a line, right? So another right here, and another right here. Alright. What do you mean auto constraint? I constrained it myself. I don't think this is the correct diameter that I want. So let's create another 3 millimeter. Boom. Right. This point will be symmetric around this point. Perfect. Alright. put some constraint into it if we want to make sure it will stay in place. I think it should be the center point. Do we have a center point? No, we do not. Okay. So let's create some reference geometry. Turn off the plane. This edge and this edge will be our constraint, and we want to sit right in between, and we will do that by create another point. Yeah, we create some other point on this. That and that. Can this point move anywhere? No, it cannot. Can this thing move? No, they cannot. So this point and this point will be symmetric around this point. Perfect. Okay, perfect. They are all fully constrained. I think I should toggle. I guess they don't need to. GN. They don't need to be. Okay, they're just a point. They're just a point. No, they are not showing here anymore. So that's good. Yeah. We'll call mounting nose. We have a hole generator. Yep. Alright. We have our hole generator. The profile will be metric fine. What is the difference? God damn. I think we don't need that. Regular profile, and it is M3. Let me check the dimension. Length doesn't matter. Would we do all through? So the K is only 2mm, right? We need to select the countersink first. FreeCAD, no. Cutout tab, countersink. Diameter of the countersink. DK. Yep, DK. DK is 5.3mm. I think let's metric fine. And M3. I think it's the same fucking thing. It's not matching what I'm seeing from the manufacturer right here. Countersink angle 90 degree, perfect. That is the K thing, right? That K is 2mm. What the? Go back. That is 2mm, and the diameter of this DK is 5.3mm. Keep pressing enter when I wasn't meant to. 5.3mm. Depth of the countersink is 2mm. Go to roll. Countersink angle 90 degree. I think we got it. Let's capture the image. It's like a bit like a project management right here. Paste it. What do you mean I can't paste it? I have to go to. Give me a second. I'm managing this thing. Picture. Screenshot. What is the latest? This one. Oh, it's a glitch from Far Cry game I was playing before. Stupid game crash. Okay, we'll name it um, mounting screws to die. All right, I think we are all set. Boom, 3 beautifully made M3. Let's check with the let's check it with the ruler. How do we measure the diameter? The radius, yeah. 2.65 times 2 is 2.5. 2.5 is 5, right? And 15 plus 15 is 30. Yeah, diameter is correct. Okay, close it. Yeah. Oh, the inner diameter also. So radius of the inside hole is what 1.7. That doesn't make any sense. Yeah, wait, this is M3 not 3 millimeter. Diameter of M3 screw, yeah, should be 3 millimeter, right? Why is it 1.7? What the hell? Oh, what? Okay. Is the radius 1.7 plus 1.7 is 3.4. 3.40. Yeah, 3.4 millimeter. Is it the clearance it is giving me? 3.40. Yep. Let's close it. I think this is good. But I like the standard is okay. 3.4. Because clearance is a bit bigger, right? No, I can live with that. Okay, cancel. I'm not changing anything. Okay, this thing is going well. I think we can close it up. I don't see any point in trying to do more on this. Maybe we can add some details. This is good. There might be some difficulty printing it. But as far as I can see, nothing seems to be. So this will be the face that touch the bottom. The rest will be just walls. They will print it like this. So the layer lines is not a weakness. Because it will be printed the easy way, the flat way. It might break off right here due to the snagging, but if it's printing this way, it will have to flex through the strongest part, flex the strength of the material itself. Yeah. Let's add some chamfer. I feel really tired for some reason. Let's change the voice. I felt really tired for some stupid reason. But let's try to clean this up, right? Delete. Right. 2.99. Yes, yes. Okay, go to select mode and start. Should it be 2.99? No, it should not. How about 1.5? Okay, and we can also let these corner share the fillet. Maybe 1.49. Okay, beautiful fillet right here. Also here. Yep. I think I have made some stupid mistake. I think I need to change it up a bit, especially what happened to LED cutout. Some error. Can I check it? I think I don't understand what is the problem. Search set extra. Yep. Nothing seems to be error. Google time. The error is sketch not fully constrained. The entire thing, the problems, the entire thing is okay. Wait, I cannot. Oh, okay, sorry, wrong tool. Okay, wire not close 6 times. Constraint invalid. That's a new one. I want to create the bevel right here in the design and not rely on some other tool. So can we this line 45 degree. What the? Oh, okay. That is not what I expected, but let's try again. Should be perpendicular. Now, alright. Okay, it is now perpendicular, and this point is to coincide. Not like that. This point is to coincide, but not like that. The problem is the entire thing can now move. Wouldn't it break the? Okay, it's not breaking any other constraint because it is technically still under constraint. Okay, the stupid thing is still 45 degree if we extend it. So we need to, how do we lock this thing in place? We add a constraint for this. 16, is it really 16 in the real world? Yes, 16 millimeter. 16 millimeter. Okay. And yep, still moving. But you can now choose this and this. You can now choose this and have it coincide. Alright, but wait, does it just break the 45 degree rule? Yeah, I think it just broke the 45 degree rule. 45. Alright. See, we got it. I think the same problem. Same problem for this. So we first coincide the 2 point, lock it up, and these two should be 45 degree apart, and we'll trim the outer edge. Fuck, we will. Okay. Got. Alright, okay, I see what it's doing here. In order to have the sketch, I'm gonna have to give up some other sketch. So it's easy, so just constrain it. Okay, not enough, I see. Oh, okay. It. Alright. Let's create some symmetry. 2 point and a line works, right? Alright. It moves together now. A bit better. I want to create another line here, but I will mark it as construction. solution geometry, and this will have the 45-degree, right? And so does the other. So now, okay, now we just need to add a, yep, elegant solution. Oh, okay, I think we're getting better together now. I can feel I'm getting a bit better. Boom, nice. What do I tell you, baby? I think the printer can handle this because it's not cantilever. This part, however, is cantilever, so we did need to address that. Okay. Nothing seems to be out of order. We can close. Yep. We can finally add the fillet. And with a dimension of 1.49. Mountain, we push it in, we plug all the cable, we add a heatsink, and we glue the heatsink in place. Wonderful. And that is it. Remember, the learning is a journey of 1,000 miles, and it begins with, no, let's do it again. The journey of 1,000 miles begin with a single step. So stay tuned to see my next step, and I wish to see your next step. It's so corny, like let's keep it simple. The journey of 1,000 miles begin with a single step. So stay tuned for my next step. Thank you for watching. See you again.